Hi, everyone. Welcome to my presentation. Thank you so much for inviting me to talk about my research. This presentation is called User-Centered Knowledge Graph Design. And my name is Tasha. I am originally from Serbia, and that's where I did my bachelor studies in life information sciences. Then I did my master's in 3 countries in Europe. I got a scholarship to do that. It was in digital library learning. After that, I came back to my country, and there I worked uh, for 5 years in the National Library of Serbia. This is the nice big house and institution where I worked on different e-services, starting digital libraries and digital archives. But then I moved to Hawaii to do my PhD in communication information sciences, which is an interdisciplinary program. And there I started teaching in LIS school. I taught there for 5 years as a teaching assistant and instructor of record. And then I finished my studies. So now I work as a digital archivist and the project manager and at UH Manoa, where I did my school, but I also work in church archives. So this is a little background about me, but I'm going to talk about my PhD study, my research, uh, which was around creating information systems. And I was always interested in this spiritual aspect of how we are all connected and what does that mean? How does that make sense in the greater scheme of things? So I wanted to explore more about information systems that are based on networks. And knowledge graph is a manifestation of such network. So I wanted to see how we can visualize things through this network, through these networks. Yeah. So another aspect of this research is about tacit knowledge exchange and how we can include people in information retrieval loop. So, what is a knowledge graph? Knowledge graph is a term that was popularized in 2012 by Google when they introduced their schema.org. And one of the definition is that it's a graph of data intended to accumulate and convey knowledge of the real world, where nodes, these are the nodes, are entities of interest and edges are relationships between these entities. So I'm not sure how much of this you have covered in your lecture so far, but there are several ways to express these graphs, and one is through the semantic web standards, such as OWL, such as RDF, and another one is as a labeled, so-called labeled property graph, whereas my research is uh, more of the second. So this research that I'm doing, it's a case study. So the application is of my PhD program, which is Communication Information Sciences, which is interdisciplinary program. So I'm taking a snapshot of somewhere like 10, 12, 20, how many these years? 12 years, 14, I don't know. It was 10 at the beginning, but then my dissertation was lasting longer than I expected. But anyway, I captured the information in that period that happened at University of Hawaii at Manoa. And in this program, in any given moment, there are around 30 students, over 40 faculty, from 4 different departments. One is library information science, other one is information computer science, one is the business school, information technology management, and one is school of communication. So each student has to create this, so to say, committee of 5 people that need to be from at least 2 different departments to make it interdisciplinary research. So for this system, CAS PhD students are the end users. And me as a researcher, I am an insider to this research, which has its benefits, which are that I know the people, that I know the jargon, that I know a lot about the program because I was there for a while before I started studying it. But there are also disadvantages, being that sometimes I might have encountered this confirmation bias on my side, or they're being nicer to me than maybe they would be if I weren't their peer. Uh, and Yeah, just they don't want to offend my baby, saying that it's ugly. So I might have had a little bit better results than I might have had if I went to the different environment. Uh, the problem that this case study is addressing is facilitating information discovery for this population of students by pointing them out to relevant information resources that are necessary for their success. And that is helping them to discover collaborators, in the first place, supervisor, that is the most important factor in their satisfaction with the program, in their retention, but also dissertation committee members. So those resources can be human resources or other online resources, such as information on courses and exams, projects, conferences, labs, and so on. The research approach is of human-centered design, where I included the value-based design. So the values of that particular group were implemented in designing the system. And the theoretical approach was the activity theory, which is, when applied in the design, is kind of like a goal-oriented approach. And for this population, the goal, there are several milestones and goals that we need to take in order to come to the overall goal for us all and for you all, is to defend the dissertation. So basically, we have to take courses, we have to pass exams, publish a paper with faculty, find a supervisor, form a committee, propose this research, and do the research in order to defend this dissertation. So these are the goals that are outlined by the policy of this program. And this next slide is intended to give you some time to think about, so you can do that individually. In this case, think about what are the goals for your particular program. So what do you need to do in order to get to the end and graduate? But not only what's on paper, what needs to be done, what are the qualitative aspects that might influence your experience? So you can write that next to that, one of those points that you're gonna make. So now I'm gonna ask Monica to pause, or if you're watching from home, just pause this video and give yourself some time to think about what it is that you need to do in order to finish your program. Okay. Okay. Hopefully you have noted down the goals or activities that needs to be taken in order to reach this goal. And this is the literature review and the relevant literature behind this research, and it's threefold, really. Relevant research is pertinent to the PhD experiences of people who dare to go on that path. And unfortunately, there is a whole lot of stress and strain related to doing your PhD. And some research shows that like half of the people will have depression, anxiety, or both related to their studies. And then one of the most detrimental or most important factors with regard to student satisfaction and retention in the program is their relationship with the advisor. with the faculty in general, but then with the scholarly community as such. Of course, a lot of it is dependent on the activities and opportunities that one might take advantage of, but also the peer interaction. And sometimes the lack of clarity on program structure and choosing a topic may influence that. But also peer mentorship is shown to be beneficial yet underutilized. Another relevant information research area is around information sharing in academia. And researchers have noted that there is this culture of so-called social information sharing, or others call it serendipitous altruism. That sounds like casting a spell, but it's basically what you call here in the US water cooler talk. When you bump into someone, the exchange of information happens. And this is where you find out this really important, this crucial aspects, a little bit of gossip, but this really important information that you can't find online. Not everyone has the same access to these networks where this knowledge circulates. And sometimes some groups of people are excluded from that, or representatives of some groups of people. And you can imagine that happened to all of us during the COVID pandemic when we were all locked in. So we couldn't get to this social information sharing very easily unless we chatted with somebody. So it has to be like actual seeking and not serendipitous exchange. So now you can pause again and think a little bit, what is that makes your, possibly not everyone will have that experience, what makes your path towards degree potentially stressful, and what are the possible ways to remediate that? Finally, the third area of relevant research is scholarly networks, related to scholarly networks. So it's a very common way to represent information systems in academia through networks. These recommender systems are often based on publication metadata, where you can see who is working with whom. This is the co-authorship networks, but also, this kind of way of functioning is intended for the experts. In our case, that is intended for students. Other students are equally important sources of information, and they're not traditionally included in expert recommendation systems because they're not experts just yet. Also, these recommender systems that are based on publications, they take consideration only few dimensions. It's often a topic or maybe keyword or publication venue, co-authorship, but they concern it all. They say that 3 dimensions are considered as minimum to understand the full complexity of social structures. So we need more than 3 really to get the better picture of what's happening in one environment. And then scholars do wear many hats. So they're teaching, they're mentoring, they're researching, publishing, the administrative science. So all of these activities should be represented, not only the publication that is output of research. So therefore, this knowledge graph that came out of this research that ended up to be this so-called multiplex graph or multi-layered graph, where nodes have different relationships in different dimensions. For example, my supervisor, Dr. Rich Gazan, he's also my boss at my work. So that is not something that is easily you can find on the web that easy unless I put it there. You have to do your own research to see who is the boss, who is the chair of that department, and add one and one. So basically, the more nodes you show in the picture of these multiplex graphs and the more dimensions you want to depict, the more complex it gets. So that aspect of visualizing multiplex graphs is unresolved area here. This is the research design of my study. As I said, it's a human-centered design study where the humans are in the center of the design effort. And there are 3 stages to this study that were published through 3 papers. So this is a 3-paper dissertation. And the first stage is requirements gathering stage. The second stage is around design of graph database and visualization. And the third phase is evaluating this graph. And there are multiple methods that were used in different or reused in different stages. It all started with content analysis. That was like the beginning warm up, so to say. And then interviews and usability study were done in pretty much all stages, especially interviews. And then participatory workshops were done in 2 stages, the first and the second. And of course, computer science, because it is an information system. So a little bit of querying, a little bit of network science, and so on. The workshops were also followed up by questionnaires. So this is whole soup of methodologies. So I'm going to talk about each of these stages of the study. And the first one is going to be the requirements gathering study that was based on semi-structured interviews where I interviewed 8 people. 6 were students and 2 were alumni, out of which 4 were domestic students, 4 were international students, out of which 4 were new students, 2 were in the proposal stage, and 2 were alumni. So I have kind of like a distribution of different views and different type of people. The analysis of these interviews was done through NVivo software. And only students of the program were asked to do the Think Aloud protocol usability study of the CIS website, where I gave them some tasks so they commented out loud as they were looking for faculty they could collaborate with, information courses, and so on. So the findings of this study is that this program is very loose. Not everyone is very sure what they're supposed to do, and not everyone knows what others are doing. However, they do rely a lot on information they get from other people, more than the information they get from online sources. And it's going to be different for international and domestic students, the information they're looking for. I'm going to talk about it a little bit later. But the bottom line is that it's not a very coherent group, even though it's 30 of us at that time or now. There is not enough chances to do this social information exchange. They don't know each other very well. And also their information needs will change depending on the stage of the program. So naturally, in the first stage of the program, they need to know about the courses, then it moves to the research, and it moves to different problems. But some of the quotes is that I pull out from these interviews, that people go to senior students because they have more experience, and some of them would like to share their experiences in a systematic way. However, they don't want that to be attributed to them. So some kind of privacy needs to be honored there. So based on this data, because it's very important for this population to not reveal this student 1 said this and student 2 said that, because public for this research are supervisors, all of us. So it was very important to protect their privacy. And I reported findings through two user personas. One is a domestic student, Brian, and international student, Petra. And they have somewhat different timeline in mind, which is really important for both because they want to plan ahead what they need to do in which period of time, where Brian wants to finish it quickly and Petra is not in a rush. She's in Hawaii. Okay here. But also it's a different way how they look for supervisor and how they seek for information, where Brian is gonna do a lot of information seeking ahead of time. He's proactive. He has read the policy and self-reliant. But if he needs more information, he's going to go to faculty to get to the program chair, to supervisor to get that information. So the use scenario is going to be specific curiosity. I know what information I'm looking for. Whereas Petra is more of taking it a day at a year at a time. And the quote is, I will cross that bridge when I get to it. And it's relying a lot on information that she can get from other students. So it's more of an exploratory search scenario for her. For all of them, it's important to get more advice from potential research supervisors. It's a big decision to make, to get introduced to others in community, and to find potential collaborators to form this dissertation committee. So the second stage of the study is a graph model design, and it was done through 3 workshops. Whereas the first one was prior to COVID, so it was asynchronous, and then I wanted to validate findings from the previous part of the study to see if what I found in the first part of the research was correct or not. So we did some surveying and we discussed. The other 2 were online fully. The second workshop was crucial here because it was intended to design the ingest of the student data form. Because of FERPA, we can't really get their private information from any system. It has to be student contributed. So basically, the information that others will have is that information that these students will voluntarily give. So we wanted to make sure that the form makes sense. It's not too complex to put in your data. And there was a lot of discussion on privacy there. And in the end, we talked about different aspects of the program that were helpful and not helpful. Each of these workshops was including this participant check component, where I would show that graph model at that time. We discussed it and then changed categories, or at least how we name them, add categories based on their needs. And this is my graph model as it evolved through time. This is when I first started thinking about it, then formalizing it. Then I presented it in October 2018 as a poster at International Semantic Web Conference. And that's where I realized that I'm doing a mistake that most of computer scientists, because this is a computer science conference, are doing, trying to design a system that I don't know if what people think about it. It's for me, but it's not for me. It's for others. I'm very related case here. And that's where I stopped doing what I started doing and said, okay, I'm going to ask people what they need. And that's how the actual model came about. It's still more of the same. It's just differently organized, more detailed, of course. And this is the end product, this model. That has a person in the center and then 12 different categories, layers, or dimensions through which one person can be potentially connected to another person, either actually or potentially. So these are the dimensions, and I'm going to talk a little bit about each one. So each person can be either student or professor or alumni. And one of the main classes or categories here is dissertation, because we're all about that. So the dissertation mentorship network is one of the core networks here. And then another one is the publication co-authorship network. So these are the main kind of like products of people's work or publication dissertations. And of course, there is course and exam that is very important for students. So the relationship here is has taken a course or is teaching a course, because this is another provenance of the statement of somebody's expertise. If I teach a course on creating digital libraries, that means that I know something about that topic, even if I didn't publish on that topic. And that's important, especially for students. The same goes for the exams, where they have taken it or are committee members. And then for these two, there is this attribute called privacy level, meaning that you can make for the reflection. So students were able to leave their comments on the courses they have taken or exams they have taken and say whether they want this comment to be public, only for the CIS students, or private. If it was private, then the person is not me, for example, by name and surname, it's an anonymous note. So that's a workaround to still allow for sharing information, yet anonymously. There is a lot of thought on that, and we'll discuss about that later. Other nodes are more or less, except for research and lab, which is also basis of the kind of collaboration networks of people working on the same research or in the same lab, and affiliation with a department. These are mainly so-called tag nodes, so methodologies that are used for research and dissertations, tools that are used, research topic, which is a keyword, and research area, which is kind of like a discipline, but it can be an interdisciplinary research area too. And then finally, domain of application. So where this research is applied, in this case, it would be higher education. If I was to create a graph for nuclear physics, it would look completely different. And it would be that domain of application. So finally, this graph has evolved, as I showed, through time, as I talked to people in these workshops. But in the end, as I evaluated it, I still realized that there are some aspects missing, attributes missing, and should be included in the next iteration. And for example, for a person that would be international student, non-traditional student, here it's important, and then languages spoken, and so on. So here are the attributes for the person, except for the academic records, tracking their progress stage, which was one of the requirements from the first stage, what is their job position, and so on. Also, it's intended to support community building. So kind of a place to share your hobbies and interests. So you can maybe find somebody to go out and salsa with or surf, what's your neighborhood, or your caregiver of kid that's 5 year old, so we can go on play dates together and so on. So it's intended to capture more than this kind of like academic aspect of things. Building this graph was a huge task for me as a non-technical person, and it took me 1 year to capture, first design, then capture, then ingest this crowdsourced data, and I only had 11 answers. So I did created these tables mostly manually, and the data was ingested through Qualtrics form. There were many ups and downs. We used Python to ingest it into Neo4j, which is a graph database. And currently this graph has somewhere over 5,000 nodes and over almost 13,000 relationships between them. It's published, except for the students' data that they contributed. It's published freely under CC license on Figshare. It's not among your resources, but I can put it there. But these are all the different sources of data that were used for different types of nodes. So I did scrape websites, I did a lot of tagging of papers and dissertations. And the next stage of the study would be to optimize most of that. However, not everything can be optimized. And that's actually what makes this graph special, because a part of it, especially this crowdsourced data, has to be manually some input. And that's ended up to be the most valuable information, of course. The third stage of this study was about graph visualization, design, and evaluation. And it was again another workshop, and then the post-workshop survey followed by interviews. So in the workshop that was asynchronous, we talked about design for the visualization, but also I had a activity where people would vote for queries. So I'm interested in what questions are important for you in order to prepare visualizations for you. And then, yeah, this is the last part. The interviews is the core of this third stage, and it had 8 people involved. So this is the workshop this is how it looked like, where the queries that had 3 or more votes, I would convert. I would write the cipher. The cipher is the language, query language, like SQL for relational databases. Cipher is for this Neo4j graph database. So I would write a query in order to show for whatever person might be in question that query. So who are the co-authors of person, and so on. The interviews and the graph evaluation protocol was the end of this study, where I interviewed 4 new people, 4 new students, 2 second-year students, and 2 ABD, which means all but dissertation students of different stages of study, out of which 6 were domestic and 2 were international students. And the analysis was done through Atlas CI, together with my co-author, Professor Manika. And in this stage, I created this graph evaluation protocol to identify first what is the interest of that particular student, in order to kind of like informally advise them for their future steps, especially for these 4 new and 2 second-year students. So I would ask them to find the categories of their interest in these vocabularies that came out of this research. These are the tags. So for example, this is the discipline or research area, and this is how many of the resources were tagged with it. So based on that, we would do exploration. So this is the methodology and so on. So we use these vocabularies to start their search, and they had the chance to do the self-initiated exploration. And then there were 20 queries that came out of the voting exercise you just saw, and they had a chance to rate them from scale from 1 to 5, and then we talked about it later. This is not working, but give me a second. Okay, so here we are back with the video that is working this time. And this is the demo of some of the queries that were shown to the students and of the Neo4j Bloom graph visualization tool that was specially customized for this research. So basically this query is asking which course is teaching the survey as a methodology, and it shows the survey, it shows these two courses that we can explore further and see, okay, these are the people who have taken these courses, and this is one of them who has said, if you need to create a well done valid survey, this is a good class. He has left a public comment, so that might help you make decisions whether you want to take this or another class. Another query was asking who are the current students and their dissertation committees. So as you can see, this is already a messy picture because there is a lot of people and a lot of relationships between them. But still, you can see that at this moment, this professor is supervising 3 dissertations already. This is the blue links. And then this one also has 4 dissertation, 2 of which they are supervising. So it again makes you help you see how busy people are at that moment. If you need special attention, you might need somebody who doesn't have a lot on their plate already. And then this is the co-authorship network. So you can see based on the colors of the nodes that indicate the department, but the orange are alumni and students. Yellow are students, orange are alumni. So you can see who is publishing a lot in their disciplinary cliques, like those two people in LIS, or who is working a lot with students. So if you select that supervisor, you might have publication with them. That's what their expectation will be for you, probably, if they already have a lot of publications with other students. So another query is asking people who publish on the topic of social media. So this is an alumni who are publishing on that topic, but there are some professors too. The purple ones, the pink ones are the papers. So you can go inside each of the paper and expand, see other stuff in them, like methodologies that were used. So this is a survey, this is a historical research. And then let's say you pick one professor and want to explore more about them, see which courses she is teaching in order to maybe get to know her better and so on. So this is just a short demo. There was a lot more going on there, but just to give you an idea of how this graph exploration looks like. And then evaluation results show that this tool was very useful, especially for new students. And in over 50 instances, they actually explicitly said helpful or useful as a word. Especially for domestic student who is very driven to go through program really fast, they are looking for the ways to show them how to do it, and the graph is helpful there. So one of them said it's a good navigation tool. Also, it's helpful for decision-making support because you can see the previous students' activities and then compare yourself somewhat to that. And also, 7 out of 8 people said that comments on courses and exams and faculty teaching and supervising styles were extremely helpful. However, when I asked them, would you leave this comment? They were not so sure. So it's a somewhat controversial feature, and we're writing a paper on that because there are differences where international students are much more reluctant to say negative things naturally because there is more at stake for them than the US students who are brought into the free speech kind of sense, and they're paying for school, so they can say whatever they want, I guess. But also, it's very helpful to plan for a personal timeline to project in futures. So one of them said, "Oh, so this person did it in 3.5 years. I can do it then too." Another person said, "Oh, so see, this person got the job at UH, even though she graduated there, because here they don't want to hire people from this university. They want to hire people from fancy universities. So it gives them like reassuring sentiment that they can do it too if others did it. It was helpful for faculty exploration to support this interdisciplinary collaboration, to kind of find people from different disciplines, from different departments that work on the same thing, hopefully what you do. And then all of this data that was aggregated saved a lot of time looking for information, especially when using vocabularies that were predefined. And one of them said a lot of this would be difficult to find, at least altogether it would take forever. So you would have to go paper by paper and so on. One of the things that is lacking is qualitative input, because one of the queries was, it shows a timeline. How long did it take other students to publish a paper? How long did it take them to go through this stage of program or to finish the program? And it ranges from 3 to 11 years, really. So they are wondering what happened to those who did it in 10 years, 11 years. What is the reason? What happened to those who dropped out? So there are still questions to be asked. They're missing in the graph. It shows the state of things as they are, but it doesn't really show why they are like that. And another thing is it shows really a talking point. Even if you don't know someone, it points you to them, and then you can say, "Oh, I know that you work on this," or you know that person. So it gives you kind of like conversation starter. As a discussion, tying it back to the literature, this graph somewhat reduces the uncertainty, which is the source of the academic stress. It supports decision making, especially when selecting faculty based on the experiences and the numbers. You can easily see how many students did each of the faculty supervise. It kind of testifies on their behalf of how good and successful supervisors they are. Also, the model itself, it's extensible. You can add more things to it. It's flexible. Things change in program in life, so still you can do that. It supports that flexibility, but also it's good for supporting interdisciplinary research collaboration. And it includes students, as this kind of peer mentorship is underutilized yet valuable. So it includes their perspective. But also it improves visibility of activities. You can really see who is doing things and who is not doing things. So it does call for accountability. And then finally, this query picks that actual people chose for themselves was shown to be super useful, because the new students could anticipate it, and it anticipated their needs. So one of them said it answered questions that I didn't know I had, because they had it before her. So it's already there. It helped her, realize what she's supposed to be thinking in that stage of the program. And finally, this timeline feature was also very useful, especially this comparison for the driven one. Unfortunately, it can be detrimental for those who are uncertain, who already kind of suffer of the imposter syndrome and think they're not good enough. If they see that people are doing well, it can kind of backlash on them. Finally, limitations in future research. This is a hand-curated data set. As I said, it took a lot of time. I wouldn't recommend to anyone doing this at this scale. Yet it does have its advantages of that highly granular and detailed data that I don't know if this maybe with the chatbots it's possible to tag it automatically. At the time it wasn't. It's lacking this qualitative input that I mentioned, and one of the research ties into that, talking about video testimonials. So say that people when graduate they would leave their oral history record on their experience, and that would be really, really interesting on anthropological, not only useful side of things, to have kind of like a archive of activities of students and faculty and everybody in an educational setting. This is not a representative case, the CIS program. However, other iSchools could potentially implement such a tool, especially because if they want to foster this interdisciplinary research, but it should be applied in other disciplines other than information science, tangential research, to kind of validate the usefulness. Also, expanding user population in academia, such a graph could be helpful for other stakeholders. And we did the preliminary, Monica and I did the preliminary research on this, and it shows that especially program coordinators would have a great use of such a tool because there is no such database for them. You have to track the progress and who is doing what with whom. And finally, the next step, because I have listed the design specification, is to actually design this novel tool for visualization of multiplex graph. And this is something that I'm thinking about every day still, and still it didn't materialize. Hopefully it will. And some of the questions are: what are the challenges to updating this data? Will people be willing to do that? How to motivate them to do that? How can we apply the large language models to help us do it? How can this be a tool for new age librarians and archivists who would keep these graphs for their department they're serving or school they're serving? And can we use this to help to foster socialization between people, to support the tacit knowledge exchange? And whether this could be useful in other than academic settings, not only in universities. And these are the references, and I will share these slides with you. We don't have ability to talk, but I wanted to show you a tool that is also related to this Neo4j tool that I was using for this study, and it's called Arrows tool. And so based on the exercise you did earlier, you can create your own graph database sort of model. And I'm going to share with you now. Okay. This is the actual tool, but there is a video. So let's do that first. Let's see if it's gonna. Okay. And there is a little intro video. Great.
Arrows.app is drawing pictures of graphs. It's a great way to make pictures for web pages, documentation, and for presentations. So let's have a quick look at a quick example. Click to make a node, hover outside, and drag to make relationships. Then a guide to keep them in place and they stay connected. But for the moment, let's go back by undoing and double click to type Tom Hanks. Press enter is another alternative and type Cloud Atlas. The relationship type is acted in, but the nodes are a bit close together, so we'll move them apart. Now we'll choose a theme. Here we chose the Bloom theme, which looks a little bit nicer than the default theme. And we make another node. This is Hugo Weaving. Relationship is the wrong way around, but there's a button to reverse it. We put the acted in relationship type and line up the node to make it look nice. Time for another node. It's another movie. It's called The Matrix. Now these movies are connected via Lana Wachowski. Type in the name. let's just line that up to look nice. We need to reverse these relationships. There's a directed relationship here and acted in on the left hand side. Now this is looking good enough to share, so let's give it a name. If we've used Google Drive for storage, we'll find that the preview image turns up straight away in Google Drive, which is super nice. Let's have a look at what we can do with the images. So we press the export button, we can drag to any drawing program, in this case Google Slides. The SVG is even more powerful, so here we're dragging. We'll find that each of the individual elements are editable. Back in Arrows, and now I'm going to select, scroll around a bit, and then I'm going to select the movie nodes, give them a different color so that they stand out. But that's not really how it works in Neo4j. You can't store colors directly, so instead we use labels to distinguish different types of node. So I've selected all the people and given them the person label. Now let's do the same for the movie.
In ontology, this would be class.
They get the movie label. We can even have multiple labels per node, just like you can in Neo4j. So the actors get the actor label, and the director gets a director label. Now let's think about these captions. They're not really part of a graph model, they're very convenient, but let's turn them into properties instead. So here we've got the name and the title properties. What we see now is that if we go to Cypher, we get all those properties embedded in the cipher. So it's a really nice way.
And so on and so on. So basically what you could do is go to this website and create your own graphs of whatever you want to do. It could be about your program, or where a person could be just, this is me, and then this is Annika, and then can define the relationships. Cool. Actually, here that the convention is to be all caps, and so on. So it's kind of neat to create your own graphs if you want to publish somewhere, make just like nice looking nodes and edges sort of things. But it's also how I designed the first graph for myself when I started thinking what should a person graph have. So I created one for myself, and based on that, it helped me understand how it could look like, and what should be included too. So based on the first exercise you did, you can create kind of draft a graph database model for your program, and then just add and decorate more. So thank you for your time. I hope you found some useful information in this lecture and got intrigued into learning more about graph database modeling, and yeah, it's similar to ontologies, but it's not as rigid. It allows more flexibilities in expressing things the way you would like them to be, without imposing so many restrictions, so to say, which then loses the inference strength, but it is what it is. Thank you so much for your time and attention. And if you have any questions, please feel free to contact me. I do have a slide with my information. Let's see where it is. Yes, this is it. This is my email. And if you have questions, comments, you like to design, you want to help me out with making this new tool, let me know. Bye bye.